Hi students, so after completing the fourth question, let's move to the next question. So here we are going to apply the concept of partial differentiation of second order, and here also we have one deduction. So after proving the given result, we have to find out the deduction and we have to deduce that result as well. So let's see how to do that. So here the value of x is given as e to the power r cos theta cos of r into sin theta, and the value of y is also given in terms of r and theta, and we have to prove these two results and then we have to deduce this big result. Now guys, how to do this? So let's take one by one. So let's forget about the deduction. First let's focus on the prove that, and in that also I'll focus on the first result. So in the first result I have to prove the value of del x by del r is equal to 1 upon r del y by del theta. Now how to get that? So here since x is given as function of r and theta, I can easily differentiate x with respect to r. Similarly, I can easily differentiate y with respect to theta since the y is a function of r and theta. So let's find out these two values, put this result over here, and let's see if we are getting this result or not. So let's start. So here I'll say del x by del r equal to. So guys, to find this value, I'm going to differentiate partially this x with respect to r. So here in these two functions we have r. So here I'm going to use the product rule of derivative. So e to the power r cos theta will remain as it is. Derivative of this cos is negative sine of r sine theta, and again the derivative of this r sine theta with respect to r. So sine theta is a constant and derivative of r is 1. So this is the value. Plus now cos of r sine theta will remain as it is, and we'll find out the derivative of this function. So it is e to the power r cos theta into cos theta since we are differentiating with respect to r. Now guys, here we got the result. Now from these two terms we can take e to the power r cos theta common. So here we'll get and now in the bracket let's see what remains. So from the first term this sine theta and negative sine of r sine theta will remain. So here I'll write down negative sine theta into sine of r sine theta. Next, from the second term cos theta and cos of r sine theta will remain. So plus cos theta into cos of r sine theta will remain. So guys, this is the value of del x by del r. Now let's find out del y by del theta, and for that we will differentiate this y with respect to theta. So again in y there are two functions multiplying each other and both have theta. So again I'll be applying the product rule of derivative. So we will get del y by del theta equal to. So here e to the power r cos theta as it is, and the derivative of this term with respect to theta is sine will become cos. So cos of r into sine theta, and again we will differentiate this r sine theta with respect to theta because we are differentiating with respect to theta. So r will remain as it is, sine theta will give us cos theta. So r cos theta is there. Now plus this sine of r sine theta as it is, and the derivative of e to the power r cos theta with respect to theta is e to the power r cos theta into r as it is, and the derivative of cos theta is negative sine of theta. Now from this value again we can take e to the power r cos theta common and r common. So we will get r e to the power r cos theta outside, and in the bracket from here cos theta will remain and cos of r sin theta will remain. Similarly from here r and e to the power r cos theta outside, so negative sin theta is there into sine of r sin theta is there. Now guys, let's call this as equation number 1 and this one as equation number 2. Now if you see the first result, then in that here we have to multiply this del y by del theta by 1 upon r. So what we'll do is we will just assume it. So just assume that I am multiplying this del y by del theta with 1 upon r, or we are dividing with r. So if we divide with r, this r will be cancelled and we will get remaining function as it is. But guys, if you'll observe this remaining function, then it is exactly similar to this equation number 1. See here, e to the power r cos theta is there, cos theta cos of r sin theta is there, and negative sign of sin r sin theta is there. So it means we can say that therefore the value of del x by del r is equal to 1 upon r del y by del theta. And guys, here we got the first result. So we'll call this as equation number 3. So here I got this result from the comparison of equation number 1 and 2. Now let's move ahead. So let's find out the second result. So guys, I am sure that you will be able to find it out. So for this, what we have to do is you have to find out the value of del y by del r. That is, let's differentiate y with respect to r. Then we'll differentiate x with respect to theta. So let's see. So I'll help you out in this. So let's find out del y. So the value of del y by del r, by differentiating this y with respect to r, we will get e to the power r cos theta as it is, and derivative of the second function with respect to r will be cos of r sin theta, and again the derivative of r sin theta. So r will remain as it is, I mean sin theta will remain as it is, and since we are differentiating with respect to r, the derivative of r with respect to r is 1. So this is the value. Now we will keep this second term as it is, that is plus sine of r sin theta will remain as it is, and we'll differentiate this e to the power r cos theta with respect to r. So that will become e to the power r cos theta into cos of theta. Now guys, from these two terms we will take e to the power r cos theta common. In the bracket, from the first term we will get sin theta into cos of r sin theta, and from the second term we will get cos theta into sine of r sin theta. So this is the value of del y by del r. Now let's find out the value of del x by del theta. So if we differentiate x with respect to theta partially, then both terms have theta. So here we will get del x by del theta equal to, so guys, now we'll again apply the product rule. So e to the power r cos theta will remain as it is, and derivative of this term, that is cos term, is negative sine. So we will get e to the power r cos theta as it is, negative sine of r sin theta into derivative of r sin theta with respect to theta. So r will remain as it is, sin theta will give us cos theta, plus, now this time cos of r sin theta will remain as it is, and we'll find out derivative of this e to the power r cos theta. So cos of r sin theta e to the power r cos theta into derivative of this. So r is as it is and derivative of cos theta is negative sin theta. Now guys, again from these two terms, this first and the second term, we are going to take e to the power r cos theta common and r common. So r outside, e to the power r cos theta outside. So in the bracket, from here we will get negative cos theta into sine of r sin theta, and from here we will get negative sin theta and cos of r sin theta. Now guys, let's see the required result. So in required result, this term, that is del x by del theta, is multiplied by negative 1 upon r. So if I multiply this with negative 1 upon r, then guys you can see here that I can take this negative sign outside, which will become negative r e to the power r cos theta, and then we'll multiply it with negative 1 by r. So let's see what we get. So here I'll say negative 1 by r del x by del theta equal to. So this r in the denominator will be cancelled with this r, and this negative sign which we are taking outside will be multiplied with this negative sign, and that will become positive. So it means we will get e to the power r cos theta, and in the bracket we will get these two terms again, but both terms will be positive. So now guys, if you'll observe this result with the value of del y by del r, so let's call this as equation number 4 and this as equation number 5, then you'll find that right hand side is exactly same. So here we got e to the power r cos theta. Similarly here, one term is sin theta cos of r sin theta, here cos theta sin theta cos of r sin theta, this is the first term, and the second term is cos theta sin of r sin theta, which is there, that is cos theta sin of r sin theta. So since right hand side of equation number 4 and 5 is same, we can say LHS is same, therefore we'll say the value of del y by del r is equal to negative 1 by r del x by del theta. And guys, here we got the next result. So let's call this as equation number 6. So it means we have proved these two results. Now let's move to the deduction. So in the deduction we want the second order derivative. So if you see here, we want del square x by del r square, and for that we will differentiate this first result with respect to r again, because due to that here we will get del square x by del r square. So this one is the result number 3. So here you can see that this is the result number 3. So I'll differentiate this equation number 3 with respect to r partially. So by doing this, here we will get del square x by del r square equal to. Now guys, if we'll differentiate this right hand side with respect to r, then first term already contains r, but also in the second term we have r, because it's a value of del y by del theta. So why it is said that y is a function of r and theta in the question here. So we said that it is given that y is a function of r and theta. So it means y also contains r. So since I want to differentiate with respect to r, we are sure that there is r which is present in del y by del theta. So that is why for this two function I am going to use the product rule. So that will become 1 upon r as it is. Derivative will be del square y by del r del theta. Then plus del y by del theta as it is, and the derivative of 1 upon r will be negative 1 upon r square. So let's call this as equation number 7. So here I got the first value. Now to find out the second value here, that is del square x by del theta square, we have to differentiate this equation with respect to theta partially, so that here we'll get del square x by del theta square. Now guys, this result is our equation number 6 here. So we'll rearrange this, we'll send this negative 1 by r to that side, so that will become del x by del theta equal to negative r del y by del r, and now we will differentiate this with respect to theta partially. So we will get del square x by del theta square equal to, now negative r is a constant since it does not have theta, and the differentiation of this with respect to theta partially is del square y by del theta del r. Now guys, to this value we have to multiply with 1 upon r square. So this will become 1 upon r square del square x by del theta square equal to negative 1 by r del square y by del theta del r. So here we got the value of third term. So we got the value of first term and third term. Second term, that is del x by del r, that value is already given. So now let's put all these values in the LHS. So and let's see what we get. So LHS, first we have to put the value of del square x by del r square. So its value is equation number 7. I'll put this value, so that will become 1 by r next. The second value, that is 1 by r plus 1 by r as it is, and the value of del x by del r, which is 1 by r del y by del theta. So if I put this value over here, that will become 1 upon r square del y by del theta. And now last value, that is 1 upon r square del square x by del theta square, and that is equal to negative 1 by r into this. So I'll put this value. Now guys, let's cancel the similar term having the opposite sign. So see here, this term is positive and this term is negative, we can cancel it. Again this term is positive, this one is negative, we can cancel it, and it means we are getting nothing, that is we are getting 0, and therefore we can say that the value of this result is equal to 0. So therefore we have done the deduction. So guys, here we have completed the problem, and I'm sure that you understood how I got the given result as well as the deduction. So guys, don't forget to share this channel with your friends and share this video with your friends, because here I've completed my role. Now it's your role to promote it to your friends who want to learn the engineering concepts in a much easier manner. So keep watching Ekeeda channel, and if you want the complete course of this mathematics and other subjects of engineering, then do visit to ekeeda.com to get the course. Thank you very much.